Hi, this is Curtis from TI, and this is Visualizing Quadratic Expressions. We're going to do part 2 in this section. This time we're going to explore the connections between the area models we explored in the last video and both their arithmetic and their graphical representations. So hopefully you guys can get a lot out of that. Let's dive in. First thing you guys should notice is this is the same area model we were using last time. And so we have a variable x, and remember we can move this around a little bit and see that this truly is a variable x that is the side of this small square here. And so the sides of this larger square, this polynomial here, is our x plus 1 unit and x plus 1 unit. And so we can write this, this polynomial or this representation of it as, we'll say it's x plus 1 quantity squared. And so what we're going to be looking at in this particular video is ways to find equivalent expressions to that, and then ways to verify those and make connections among those. So first of all, let's start off with kind of the basic one, or maybe the expected one, which would be if we click each of those two pieces and make them separate, and then this one separate. What we have here is kind of a representation now of x squared. This area here is x squared, and each of these will have an area of, say, x times 1, so that's x. So we've got 2x, and then we have an area here of 1, right, because 1 times 1, so the area of this is 1. So we have effectively a new one which would represent, we'll call this x squared, and we'll call the next one plus 2x, and then finally we have plus 1, right? And so we have one verification there. Well, this is how we would write it in an algebra notation. Now let's actually insert a page, and we're going to go through the process of maybe verifying this using a calculator page, and then ultimately we'll go to a graphs page as well. So first thing we're going to do is we're going to insert a page into this document, and so I'm using a TI-Nspire software, the student software, and so you can insert a page a number of ways. If you have a calculator at home, you can certainly do this by clicking on the calculator software and pressing the control key and the dock key, so for control and insert page, or you can use control I. Either one of those will insert a new page. That's what I'm going to do here on the computer. So I'm going to press control and I and get a new page, and I'm going to insert a calculator page. On this calculator page, let's just type in the expression over here that we have on the right to see that we did our algebra correctly. So let's type this in. We're going to type in x plus 1 quantity squared. So I'm going to press quantity squared, and then we'll type in the equal sign, and we'll get x squared plus 2x plus 1. What we're using here is called a Boolean operator, and basically what we're going to get is a true or a false to decide whether the expression on the left-hand side of our operator, or sorry, the expression on the left-hand side of our operator there is equivalent to the expression on the right-hand side of our operator. And since we don't have a complicated expression that needs to be simplified, we can just press enter and we'll get an answer that says true. And so the result that we get here shows us that the expression that we have on the left-hand side of our operator is equivalent to the expression on the right-hand side of our operator. So this statement is in fact true. So we got our true statement, and that shows us that we did our algebra correctly, which means that the picture that we had over here was in fact x squared plus 2x plus 1 that we showed here on the right. That's one way we could verify this. Another way we could verify this actually would be to insert a calculator, or sorry, a graphs page. So I'm going to, on the software, I'm going to select insert, and I'm going to insert a page, and I'm going to insert a graphs page. And on that graphs page, I'm now going to type in our first one, which was x plus 1 quantity squared. So I'll do that to begin with, x plus 1 quantity squared. I'll type that one in, and we'll get that graph. And just for consistency's sake, we'll change the color so that it's the same color as what we had a moment ago. So x plus 1 quantity squared, that's going to be our original function. That was our original problem. And now we'll type in this second expression into F2. So I'm going to press Control G to get myself another graph entry line. And so I'm going to just type that one in. So x squared plus 2x plus 1 will give me a second one to verify. Now that one turned red also, so I'm going to hopefully get this one to be just a little bit different color. Maybe I'll make this one blue instead. Okay, and you'll notice that they graphed right immediately on top of each other. So f1 of x, x squared plus, or sorry, x plus 1 squared is equivalent, at least graphically, to x squared plus 2x plus 1. So we can verify that in a number of ways. We can also press the trace key. So I'm going to select that from the menu, and I'm going to just grab my trace, and notice I'm on the red graph here. I can see that both of my values, whether I'm tracing up or down on either of these two graphs, I can see that the values are equivalent in either one of these, F1 and F2. It doesn't matter. I have a completely equivalent graph, and so I can verify that my algebra was also correct a moment ago. So this connection here, this expression is equivalent to the original expression x squared, x plus 1 quantity squared. Now let's try a different expression. Let's try separating this out just a little bit differently. So I'm going to separate out just the 2x, and I'm going to leave the x attached here. And you may remember from the previous problem, or from the previous video rather, that when we did this, how we handled this, we had the x plus 1 quantity squared, and we're going to check this one as well. So this one we decided we could actually write a little bit differently. We could actually write this as the quantity x plus 1. So down this side we have x plus 1 on this side multiplied by x. That would be the area of that rectangle. So you guys might remember that from last time. So we're going to say x plus 1 times x. That's going to be the area of this first rectangle, but we have this dotted area that's removed, right? And so what is this dotted area? Well, it's the width of x minus 1, right? So that would be just this section. So this would be x minus 1 times 1. So that little area that we have removed would be x minus 1. So that's that section. And then we have the plus 2x that we had before. So we can add to that plus 2x. So we have that section as well. So now let's just go back through our same process and verify this. So this time I'm going to take a value and I'm going to store it into my value of x, because traditionally you really need to do that to make sure that this Boolean operator works appropriately. The first one worked okay because we didn't have any simplification that could have been done. So let's store a value. I'm going to store a value pi into our value for x. Just some decimal value is totally fine. So I'm going to store this using control and the var key. Control and the var key gets me the sto, S-T-O, store operator. So I'm going to get that, and I'm going to store that value into the variable x. So I'm just going to store pi into x, and that's what has happened here. And now I'm going to use this same expression that we did before, only you'll see my x's are now bolded because it's a variable that actually has a value in it. So I'm going to check, is x plus 1 quantity squared equivalent to the expression that we built over here just a moment ago using our area model, which was x plus 1 multiplied by x, subtract the quantity x minus 1, and then add 2x for a different expression that we could have gotten. And I believe we did our algebra right, but now we can have a way to check that or verify that using the calculator page, and we get a true. And so if I go here to this to our graphs page, I would expect that if I add that same graph here, so if I do x plus 1 multiplied by the quantity x and subtract the quantity x minus 1 and add 2x to it, I should expect that this graph will also land right on top of those other two. And as a matter of fact, it appears that it does. We can use the trace to verify that, but that's another way we can mess with this. So now we have all three of those graphing all at the exact same time. We can also use the feature trace all to just show that for all three of those I have the exact same value no matter what value I have for x. So now what I'd like you to do is I'd like you to, on page 1.5, your 1.5, if you haven't inserted the graphs pages as before, but if you navigate to the page that looks like this one, where we have the quantity x plus 2 times the quantity x plus 1, I want you to navigate to this page and make a couple of expressions that you can check and verify. Pause the video right now and play with that and come up with some conjectures for yourself. Okay, so you probably maybe investigated the very first one, the kind of common one, which would have been x plus 1 times the quantity x plus 2. Apologize there for the handwriting. So you probably got x plus 1 times x plus 2 and checked that to be equivalent to kind of the standard one, where you separate out all of the x's and the units by themselves. And so you probably checked it against maybe this one, which would have been quantity, what would that be? X squared, I guess, plus 3x and then plus 2. So you may have had, that's a plus 2. And so you may have checked this one and verified it against the others. So we could go through that process, and I'll show you that graph really quickly. So we can have x plus 1 times x plus 2, and that gives us this graph to look at, and then we can verify that one against the other graph that we just said, which was x squared plus 3x plus 2. And you can see that those definitely graph right on top of each other. And we could also use the calculator page to do the same thing. And so we could check, is x plus 1 times x plus 2 equivalent to x squared plus 3x plus 2. And we can find that that is, in fact, a true statement, sort of what we expected based upon the work that we just did here. But perhaps you did maybe a little bit different one. In fact, maybe you played with just having maybe the two x's pulled off here to the side, and maybe these two units pulled off. And so you have x plus 1 times x plus 2x plus 2. So you might have had this. So you might have had this, and you could check that against your other graphs and see that it definitely aligns just like all of the others. You can use that trace all feature. That's a really handy one to see that that definitely traces all of them and plots the same all the way across. Or you may have chosen another one that kind of looks like this. It was pretty interesting. So you could have chosen to take away 2 of the x's and just 1 unit. And this one kind of gives you a really interesting challenge. You'll notice that you have that perfect square over here again. So you have x plus 1 times x plus 1. But we're going to subtract off the x. And then we have plus 2x plus 1. So what we're looking at here might be this. And so that one might be an interesting one to check on the graph screen as well. So we can drop that in. Notice really quickly, this could also be rewritten pretty simply. Notice I could combine those two really nicely, and I could get that this is really just like x plus 1 quantity squared plus x plus 1. Which makes for an interesting conversation about the way that this connects visually to that one. But that's another discussion we could do at another time. We could actually put that together and show that that is a nice connection to what we had just a moment ago. So both of those are interesting. So let's plot those and see what we come up with on our graph screen. So we're going to just plop that one more expression in here. So I'm going to say quantity x plus 1 squared minus x plus 2x plus 1, and see that that one also lands on the exact same space as all of the others as we did before. So just one more way to verify and check that the expressions that we're making do in fact connect to the graphical expression that we go. Be watching for another extension video for expressing quadratics and exploring quadratics using the TI-Nspire technology on our YouTube page. Thank you very much.